In today's lecture, we are going to revisit rational numbers and their decimal expansion. Okay, so rational numbers, as we have discussed in the first video, that they may be either terminating or they may be recurring. So what determines whether they will be recurring or terminating? So let a rational number be x is equals to p by q such that the prime factorization of q is of the form 2 to the power n, 5 to the power n, where n comma n are non-negative integers then x has a decimal expansion which terminates. So if it will be of the form of 2 to the power n, 5 to the power n, the denominator, then we'll say that the number x is terminating. Just for an example, let's say we have 15 by 1600. So the prime factorization of 15 is 3 into 5 and the prime factorization of 1600 will be 2, 800, 2, 400, 2 into 200, 2 into 100, 2 into 50, 2 25s are 5 5s are and 5 1s are. So 15 is 3 into 5 and 1600 is 2 to the power 1, 2, 3, 4, 5, 6 and 5 to the power 2. So solving them, 3, there is no 3 in the denominator, so 3 remains as it is, and we have 1 5 in the numerator, 2 5s in the denominator. So 5 will cancel off 2 to the power 6 into 5 to the power 2 minus 1, because when we take in division, powers are subtracted. So this is 3 by 2 to the power 6 into 5 to the power 1. So the denominators are of the form 2 and 5 and they are non-negative integers, hence this is terminating. Therefore 15 by 1600 terminates. Another example would be, say we are given 777 by 210. So 777, 7111, 3 is a 9, 21, 3 7s are 21, and 37 in itself is a prime number, so 37 into 1. And the other number 210, 7 3s are 21, 0, 3 10s are 2 5s are 5 1s are. So 777 becomes 7 into 3 into 37 by 210 becomes 7 into 3 into 2 into 5. So a 7 and a 7 cancels off, 3 and a 3 cancel off. So 37 by 2 into 5. We need to ensure that the numerator and the denominator are co-prime numbers such that they do not cancel off each other. So this is the most simplest form over here. Now the denominator is of the form 2 to the power n, 5 to the power n, where m and n are non-negative integers. They are 1 and 1. So both 1 and 1 are non-negative. They are positive. Therefore 777 by 210 terminates. And the second type of decimals that you are going to get is the recurring one. So let x equals to p by q be a rational number such that the prime factorization of q is not of the form 2 to the power n, 5 to the power m. Please note that we have a not here, means it should not be of the form 5 to the power n and say 2 to the power n and 5 to the power n. This means that it should have another prime number other than 2 and 5, where m, n are non-negative integers. Then x has a decimal expansion which is non-terminating but repeating. We also call this as recurring. That means it repeats. So before coming to the example, just a note that the decimal expansion of every rational number will have a terminating or non-terminating repeating. It is an either or situation. One of this will hold. So either it will be terminating or it will be non-terminating repeating. So let's look at some examples of this question as well. Say (64 by 455). So 64 is 232, 260, 2 8s, 2 4s, 2 2s, 2 1s, and 455 will be divided by 455 will be divided by, this is not going by 3 because the sum is 4 plus 5 9, 9 plus 5 is 14. Next we'll check by 5, so it will go by 5 because the last digit is 5. 5 9s are 45, 5 1s are. Next after 5 we'll check by 7, 7 1s are 7, so 21, 7 3s are 21, so 7 1s are 7, we have 21, 7 3s are 21. So 64 is 2 6 times, that is 2 to the power 6, and 455 will be 5 into 7 into 13. So For this now, there is nothing that we can cancel out. They are already co-prime. So now in the denominator, if you check, there is 5, there is no 2, but there are 2 digits or 2 numbers that are other than 2 and 5. Since there is presence of a prime number other than 2 and 5, therefore 64 by 455 is non-terminating repeating. Please note that this is your rough work. You need to make a margin and mention rough work. Another example. Say we have 29 by 343. So 29 is 29 itself. 29 itself is a prime number. For 343, 7 4s are 28. We have 63. 7 9s are 63. 7 7s are 49. 7 1s are 7. So 29 by 7 cube. Now in the denominator, numerator and denominator are co-prime already. There is no common prime factor in them. Now in the denominator we have powers of 7. So since there is no 2 or 5 and there is a presence of a number other than 2 or 5, therefore as the denominator is not of the form, it will be better if you mention the statement, as the denominator is not of the form 2 to the power m, 5 to the power n, where m comma n are non-negative integers. Therefore 29 by 343 is non-terminating repeating. With this we come to the end of this topic.